Hello everyone, welcome to my channel. Let's solve this question together. Look at what we are given. We are given that the integral of 3x multiplied by e to the power of 2x dx. Now we are asked to integrate this function with respect to what? X. Now this question is as simple as A, B, C, D. It's very simple. Now I want to draw your mind to what? Integration by parts. Okay, because this we are having a product. Look at 3x multiplied by e to the power of 3x. But have you heard about the DI table? The DI table is one of the interesting and the short way of what? Working with what? Integration by what? Part. So what I'm going to do in this video, I'm going to use what? The integration by part method and also use what? The DI what? Table. Okay. Now, let's use our integration by parts. We know that by formula that the integration by parts is what? The integral of what? Of u dv, okay, is equals to u multiplied by v minus the integral of what? V du. This is the formula of what? The integration by what? By parts. Now from this, our u is what? Our u, let u be equals to what? 3x, right? Okay, s is 3x, and our dv is what? Our dv is equals to e to the power of what? 2x. Okay. Now here, let's differentiate this with respect to this. Let's differentiate u. So you have that du over the x is equals to what? 3. Because if you differentiate 3x is just 3. Now let's make the s the surgery formula. That's to say that du will be equals to 3 dx by cross multiply. Because the denominator here is 1. So 1 times du is du. So if we divide here by 3, also divide here by 3. 3 will go, and this implies that the x is equals to du over what? 3. Wow, this is amazing. Now here, let's integrate both sides. So if we integrate here and integrate here, why are we integrating? We are looking for v. So if you integrate this, we are going to have just v. Okay, because the coefficient of the v is 1. So if you integrate 1 with respect to v, we are going to have v equals to. Now, if you integrate this function, remember that if you're integrating this, that means the derivatives of this, okay, derivatives of this is what? Is 2. Okay, so it's with what? E raised to the power what? 2x divided by what? 2. Okay, because in here is 2. Remember that e is constant. So if you differentiate this, is 2, and this will be constant. This is the derivatives of this. Now let's go back to our question. What you have to do is just to substitute this value you have got in this formula, and you are done. You are done. As simple as ABCD. Now let's go back to our question. Our question now is now what? The integral. Now what is u? Look at u, and u is 3x. So I mean that this is 3x. And what is what? What is the v? The v here was, look at the v was e. If because after the v, I take the integral of both sides. Right? We will know that the v was equals to e to the power of 2x. So this is what? E to the power of 2x, which is still our function we are doing. Okay, that means then the s, look at the s is here because normally it's our function. Okay, equals to, all this will be equals to what? That's what this formula is stated, that all this will be equals to this. Now let's our u is what? Our u is 3x because we're having uv here, so our u is what? 3x. Okay, then what is our v? Our v, you look at our v. Our v is into e to the power of 2x divided by what? 2. That's our word v. Then what is our, then minus the integral of what? What is our v here? Our, look at v. V is what? E to the power of what? 2x, okay, divided by what? 2. Then what is our du? Look at du. You see, we have not made du the subject. So let's make du the subject, right? So that means let's take this 3 back, okay? Because I will make the s the subject, okay? Let's make du the subject. So for us to make du the subject, you have to cross multiply, right? So if you cross multiply, what does this du equals to what? 3 dx, okay? Look at, you're making 3 times the s, you have 3 dx. So in place of du, look at du, you are going to have that this is 3 what? 3 dx. Wow, this is amazing. Very interesting, right? Now if this multiplied by this, what that this is equals to 3x, okay, e to the power what? 2x divided by what? 2. Because I'm using this to multiply by this. Then what are we going to do here? Wow. Now look at what I'm going to do. You want to isolate this and isolate this. So that this is minus 1 over 2 multiplied by 3, the integral of what? E to the power what? 2x, okay, dx. You can see we are isolate this out and isolate the 1 because there's 1 over 2 here, okay? So now go to this is equals to 3x, okay, then multiply by e to the power what? 2x divided by what? 2, then minus 1 over 2. Sorry, it will be over 3 because 1 times 3 is 1 over 2 times 3 is 3 over 2. Okay, the integral of what? E to the power of what? 2x, okay, dx. Now we want to see integrate this. So if we see integrate it, look at what we're going to have. This will be equals to 3x, okay, multiplied by e to the power of 2x, okay, divided by what? 2. Then minus 3 divided by what? 2. Then if we integrate this, I want to add this is e to the power of what? 2x, okay, divided by what? 2. Then our plus integration constant c, which is very, very important. Remember that integration constant c simply means that there are many constants that were being differentiated that cannot be integrated anymore. Okay. Now from here, you want to add that this will be equals to 3x multiplied by e to the power of 2x, okay, divided by 2. Then if we use this to multiply by the other, this is minus 3e to the power of what? 2x, okay, divided by what? 4. Then plus our integration constant c. We can factorize something. Something is common, right? What is common? What is common? What is common? You can see that 3 is common. So you can see that this will be equals to 3 is common. 3 and what? 3 and e to the power of what? 2s is common, divided by what? 2 into, because this is common. So if we divide the whole of this by this, we want to have just x. Okay. If we divide the whole of this by this, we want to have just what? Minus what? Minus 1 over what? 1 over 2. Okay. Plus what? C. Because if this multiply by this, we're going to have this back. And if this multiply by this, we're going to have this what? Back. This is the answer. Can you see how simple and interesting it is? You can see how when we use integration by part, you see this is the answer. Like, let me teach you what? Di table. Let's go. Now let's remove this from here, okay, and work on our di what? Table. Now this method is very interesting in case you are in exam hall and you want to be very fast with your work. It's very helpful. The di table is awesome. I wonder why most teachers have not taught their students about the di table. If you're watching the video, luckily that you learn about what? The di table. Now this was the di table. So let's draw our di table. This is our di what? Di table. This is our d and this is our what? I. And remember that d means what? Differentiation, and I means what? Integration. Remember, if you're watching my videos I've done on this page, I've told you guys about differentiation. The head about differentiation. Differentiation is a process, okay, it's a method of finding the derivatives of a function. And derivative is the rate of change with respect to another what? Quantity. Now what about integration? Integration is what? It's a process of finding the antiderivatives of a function. Now you'll be wondering, what is antiderivatives? Antiderivatives is like the opposite of what? Derivatives. That means antiderivative reverses the work that derivatives are what? Done. Can you see how simple and interesting it is? Now, this is the di what? Table. This is our answer to our problem, okay? But I want to show you another interesting method of solving this using the what? The di. Look at di table. This is like table, okay? Now, what I want to do, I want to differentiate this and integrate this. So, if we will differentiate 3x and integrate e to the power what? 2x. This is what we are going to do. Now, I want to draw, you also draw your mind to what? Cofactor. Have you ever cofactor of a matrix? Cofactor of a matrix. I want to go use it here. Okay, and are you about diagonal? You want to use it here. Those are very interesting. Now, yeah, okay. Now, what I'm going to do here, let's put our cofactor. This is plus, minus, plus. Okay. Remember, 3 by 3 matrix. We're working on the cofactor. You know what I'm saying. If this is a matrix, okay, that means just 1, 2, 3. 1, 3, 2, 4, 5, 6. It's like this. What you are seeing is a cofactor of this matrix, because this will affect the first line where you are finding the determinant. Okay. Now that's what I'm doing here. Okay. Very interesting. Now what are we going to do? Now let's integrate. If we integrate this, let's differentiate this. If we differentiate this, you're going to have 3. Let's integrate this. If we integrate, you're going to have e to the power of 2x divided by what? 2. If we integrate. Now if we differentiate 3, is 0. Now, if we integrate this again, you have to have e to the power what? 2x divided by what? 4. Okay, that's interesting. Now, what I want to do, as I stop this, if I got into 0, you stop, because if it differentiates 0, it's still 0. There's no change. Okay. Now, well, you're going to multiply diagonally. So let's look at how you're going to multiply. Okay, this is how you're going to multiply. Now you can multiply this one straight. You can multiply it straight. Now, that means the integral of what? 3x, okay, the e to the power of 2x. The x will be equals to, now 3x, you can see 3x times this. Look at 3x times this. We're going to have this is 3x, okay, times what? E to the power what? 2x divided by what? 2. Isn't it amazing? Are you not seeing the same thing here? Are you seeing that? It's very interesting. Okay. Now then minus, look at minus. This minus is affecting this 3. So this minus will become what? Minus 3. Then 3 multiplied by this, or this e to the power what? 2x, okay, divided by what? 4. Is it not the same thing you are seeing here? Don't plus the integration constant c, which is very important.